Hello, class. Welcome back. Today is lecture 15, the last lecture. Um, so I hope it's a good one. And today we are talking about solving rational equations, very similar to the previous lecture where we talked about just rational expressions. And now we have equations involving rational expressions that we're going to try to solve. So we're just going to jump right into it with an example. So we want to solve an equation. So it's got to have an equal sign in it. And how about this one? So 1 over x, so that's a rational expression, plus another rational expression that looks sort of weird because it's just a fraction, equals another rational expression, which is just a fraction. So we'll start easy. So 2 of these are just fractions of numbers. Only one of them is something sort of new, like last lecture. And we want to solve it. So I just want to be very clear because a lot of people get this mixed up. If I just look at this would be an expression. Or if I just look at this, these are both expressions. But once you equate things with an equal sign, so because of this guy, you get an equation. All right, I just want to be very clear. So sometimes people just like decide, I'm just going to get rid of my equation for some reason. But no, it's an equation the whole time. It's got to stay an equation the whole time. And you're trying to solve for values of x that make it work. Okay, so that was a little side note. Now on to how to actually solve it. The first thing we need to do, I'm going to break this down into steps, is first determine which values of x cause division by 0. So dividing by 0 is bad, so we want to avoid it at all costs. So in this equation here, what we need to do is we need to find places where that happens. And that only happens here, 1 over x. This will have division by 0. When? Well, if x equals 0, then you'll get 1 over 0. So x equals 0 is not a solution to the equation. It's sort of like an anti-solution. It's like the worst thing possible. It causes division by 0. So we just note it for later. It doesn't really help us solve. What it does is it helps us eliminate solutions. Okay, we'll do that later. All right, so now on to actually solving it. So what we need to do is we just need to get a common denominator. So we did this sort of last time. So we have 1 over x is 1 over 3 equals 5 over 6. So I really just need to get a common denominator on the 1 over x and the 1 over 3. So I will multiply the 1 over x times 3 over 3 and the 1 over 3 times x over x so that they both have 3x on the bottom. And then I can combine them and I get 3 plus x equals 5 over 6. And now we could do something that people call cross multiplying. That's the shortcut name for it. But what it really is getting a common denominator on both sides. So what you could do next is you can sort of think of it in 2 different ways. So one is to get a common denominator on both sides. So this guy needs an x on the bottom, so it's the same. And then this guy needs to be multiplied by 2 so that it's the same. So they're both 6x on the bottom. So then on the right now we have 5 times x is 5x and 6x as the denominator. And on the left we have the 6x as the denominator as well. And then the 2 times the 3 plus x. So then the idea is if fractions are to be equal, that means the top needs to be equal because the denominators are equal. So then we can just immediately say that since the denominators are already equal, the numerators have to now be equal. And so that's one way to do it. And then we can just continue solving for x like any old equation. So we would distribute the 2, subtract the 2x, divide by 3, and we get x equals 2. And then 2 is an okay answer because the only bad answer was 0. And we divided by 0 here, so since 2 is not 0, that's okay. So that's one way to do it. The alternative way is something called cross multiplying, but it's the same. It's actually the same. So if we start from here again, the idea is that you can multiply the 6 up to the top, and you can multiply the 3x up to the top on this side. But what you're really doing when you do that cross multiplication, that's just a shortcut. What you're really doing is you're multiplying this by 6 over 6, or sorry, you're multiplying 6 to both sides of the equation. That way it's the same. So you're multiplying 6 to both sides, and you're multiplying 3x to both sides. And then what's happening is over here, these 6's cancel, and over here, these 3x's cancel. So that's why it's called cross multiplication, because really it looks like you just put the 6 on the top of there, because that's all that's left. And it looks like you put the 3x on top on the right, because that's all that's left. So it looks like you just multiplied the bottoms across. And you'll get the same answer, so that's good news. So this is this, and then you get 9x equals 18, divide by 9, and you get x equals 2. So same answer either way, whichever you prefer to do. Okay, so now let's hop into a slightly more tough example that has things more like what we did last time, but we're going to follow the same process that we just learned. So 2 over x plus 2 plus 4 over x minus 2 equals x minus 1 over x squared minus 4. So what we need to take away from last time is how to get common denominators, and that we should be factoring rational expressions to make them look nicer. But we're going to follow these same steps. So the first step is, again, determine what x values are bad, meaning dividing by 0. Well, this just requires you to look at the denominators of all the rational expressions and just make them equal 0 so that you can discover which x value causes it. So here, if I subtract 2 on both sides, I get x is negative 2, so that's bad. And if I add 2 on both sides, I get x equals positive 2. So these are both bad. And then this one, well, actually, that just factors into x minus 2x plus 2 anyway, so you still get the same zeros. You still get x equals 2 and negative 2, which were already included. So 2 and negative 2 are the bad x values. Now, I only have to worry about dividing by 0. So 0 is perfectly fine on the top, so there's no need to set this equal to 0. It's perfectly okay to have a 0 on the top of a fraction. You just can't divide by 0. So I don't need to worry about that x minus 1. Okay, so now that I've noted all the bad x values, I can simplify by getting a common denominator. So let's see. So that what we need to do to see what we need is we need to factor all the denominators as much as possible, which is what we had to do last time as well when you're simplifying expressions. And so let's do that. So like I said, this guy factors into x minus 2x plus 2. And so what do we need to do? Well, if I want to add these two fractions together, they need to have the same denominator. So I'm going to need this guy to have an x minus 2 over x minus 2 so that they have the same denominator. And this one's going to need an x plus 2 over an x plus 2 so that they have the same denominator. And now I can put them together on top of the same denominator, x plus 2, x minus 2. Can't forget those parentheses. And then up top, this 2 got multiplied by an x minus 2, and this 4 got multiplied by an x plus 2. And then on the right, we haven't done anything. Don't forget that you can't just ignore the other side of the equation. It's also there. And so in this situation, the denominators are already the same. So cross multiplying, I don't really have to do because everything cancels and you can just set the tops equal to each other. Once the denominators are equal, the tops have to be equal as well. So I end up with just this. But doing cross multiplication is exactly the same. Okay, so now it's just an algebra equation where I have to solve for x by first distributing so that I can combine all the like terms. And so now I got to stick all the numbers to one side. So what do we got here? 4, -4 and 8 is +4. This is 6x plus 4. Subtract that 4. 5, subtract that x. Get 5x, so x is -1. And that is my solution, and it's not one of the bad x values, so it's fine. So in this next one, we'll see that the only solution is the bad x value, and so that just means that there is no solution. So that's what's going to happen this time. But same idea. X squared minus 5x plus 4. Sorry, 3 over x minus 1. So once again, we are going to determine all of the bad x values that we don't like by thinking about when the denominators are equal to 0. So in fact, I can just go ahead and set them all equal to 0 very quickly. And once again, there's going to be some overlap. Okay, so this guy factors into x minus 4, x minus 1. So 2 of my bad zeros are 4 and 1, but actually those are the same as I get from here. So I'm just repeating the same ones again. So these are both bad. Okay, 4 and 1 do not solve the equation. In fact, they make you divide by 0. All right, so step 2. Let us simplify and combine things together. So once again, I should try to factor as much as possible, and I already pre-factored this guy, so now we know how it factors. And then I can see what I should do. So if I want to combine the right side together, this fraction is going to need an x minus 4 on the bottom. So I got to multiply by x minus 4 over x minus 4. And on the other one, I need an x minus 1. So now I can stick them together. And luckily, the denominators, again, will be exactly the same on both sides, so I won't have to cross multiply. So that'll save me some time. Okay, so remember that because it's a minus this time instead of a plus, I have to keep that minus being multiplied. And now the denominators are the same. So I can just set the tops equal. Okay, so 5 times x minus 1 minus 3 times x minus 4. And once again, we just need to distribute lots of things. And then we can combine everything together. That needs to be combined. So we got 5x minus 5 minus 3x plus 12. And so what do we get here? 2x plus 7. So let's subtract that and subtract that. So I got 4 equals x. But actually, this was one of the bad values. It causes division by 0. So in fact, it's not a solution. So no solution. There's nothing that works. So it's an equation without any solutions at all. So it's sort of interesting. It has sort of like a false solution. 4 sort of works, but really it causes you to divide by 0. Okay, let's do another. So we're on a good pace here. Solve x over x plus 6 equals x, or sorry, not x, 72 over x squared minus 36 plus 4. Okay, so same thing. This one looks a bit weird because 4 doesn't seem like a fraction, but you can think of a number as divided by 1 if you really want it to be a fraction. But in any case, the first thing I need to do is set all the denominators equal to 0 to discover, oops, x plus 6, sorry, to discover when I divide by 0. So here I'll get -6 is bad, and here this factors into x minus 6, x plus 6. So I get 6 and -6. These are all the bad x values. 6 and -6 cause division by 0, so we do not want them. Okay, so now I need to simplify. So on the left side, there's nothing to do because it's by itself. But on the right side, I need this 4 to have the same denominator. So I'm going to multiply it by x squared minus 36 over x squared minus 36 so that it has the same denominator. And then, now that they have the same denominator of x squared minus 36, I can combine them. 72 plus 4 times x squared minus 36. And so I get something a bit weird looking so far. So there's a couple ways to continue. So remember that I can distribute that. What the heck is 4 times 36? I don't know. I have to cheat. Use a calculator. 1 second. 4, I don't want to do that in my head. Times 36 is 144. Okay. So 4x squared minus 144. And then down here, I want to write this as being factored, because then the left side, I can see what it's missing if I want them to have the same. I could either cross multiply at this point, or I could make them look the same. So I guess I'll make them look the same. So the left side just needs an x minus 6 over an x minus 6 to have the same denominator. And then we'll get x times x minus 6 equals, over x minus 6, x plus 6 equals the same thing. What's 72 minus 144? Is that negative 72? Yes, 70 plus 70 is 140. So yeah, good. So I could do that. And then the denominators are the same. So I can think of it as cross multiplying, but really because the denominators are the same, let me write this 72 after instead. It looks nicer. So the denominators are the same, means that the numerators have to be the same for the fractions to be equal. So now we're here. And now this is a quadratic equation. So we know how to solve these. We need to get everything to one side and then factor. So I'm going to distribute this. And let's see. So then I'm going to subtract this x squared and add the 6x. So that I just have a 0 on one side. And what will I get? So then I get plus 6x minus 72. So let's see. I think I can factor this. So 3 goes into x squared. 3x squared. I can take it out there. And then 3 goes into 6 twice. I believe 3 goes into 72, but I need to cheat again. Yeah, 24 times. So this way I don't have to use the quadratic formula. Remember, when you want to factor a quadratic, or when you want to solve a quadratic equation, first you should try to factor because that's the easiest. And then if you can't factor, then you resort to the other tricks. But I think I can factor this. So let's see. I have a negative 24 and a 2. So a 6 and a negative 4 should do it. And so because I took out this 3 ahead of time and it's just a 1 now, I don't have to do the long process when I factor. It just becomes x plus 6 and x minus 4. if I didn't take that 3 out ahead of time from everything, then I would have had to do the other version of the box method. Okay, but in any case, now it's a multiplication of things equal to 0. So I can solve it by setting each factor equal to 0. And then I get my 2 answers. Whoops. So x equals -6 and 4. But aha, this one was bad a long time ago. So in fact, the only answer is 4. -6 is sort of this false answer. Okay, so that's about as complicated as they will get. They'll all be a bit pretty similar, but that's it. Okay, so that's it for this lecture, and I guess the last lecture. So thanks for joining my class.